Choice of drum spacing. In order to ensure the smooth transportation of goods, at least 3 or more rollers should be used to support the goods at any time. That is, the center spacing of the rollers is t less than or equal to 1/3L, and 1/4 1/5L is generally taken in practical experience. For slender goods with large flexibility, the deflection of the goods should also be considered. The deflection of the goods on a roller spacing should be less than 1/500 of the roller spacing, otherwise the running resistance will be greatly increased. At the same time, it is also necessary to confirm that the load of each roller cannot exceed its maximum static load. This load refers to the evenly distributed load without impact. If there is a concentrated load, it is also necessary to increase the safety factor. In addition to the above basic requirements, the drum spacing also needs to meet some other special requirements. 1. The center distance of the double chain drive drum should conform to the formula. The center distance T equals n*P/2, where n is an integer, P is the chain pitch. In order to avoid the appearance of chain half buckle, the common center distance is as follows. 2. There is a strict restriction on the center distance of the synchronous belt arrangement, and the commonly used spacing and the matching synchronous belt models are as follows. Recommended tolerance, plus 0.5 odd mm3. The pulley spacing of the ribbed belt drive should be selected from the following table. 4. When the O belt is driven, it is necessary to select different preload amounts according to the suggestions of different O belt manufacturers, generally taking 5% 8%, that is, subtracting 5% 8% from the length of the theoretical bottom diameter ring as the preload length, 5, when using the turning drum. The recommended angle of the drum spacing for the double chain drive is less than or equal to 5 degrees, and the center distance of the ribbed belt is recommended to be 73.7 mm. Choice of installation method. There are various installation methods of the drum, and there are spring press-in, internal thread, external thread, flat tenon, semicircular flat, D-type, pinhole, etc. Among them, the internal thread is the most commonly used, followed by the spring pressing, and other methods are used in specific occasions and are not commonly used. Comparison of common installation methods. 1. Spring press-in A. The most commonly used installation method in non-powered rollers, installation and disassembly are very convenient and fast. There needs to be a certain installation margin between the inner width of the frame and the roller, which will vary according to the diameter, hole diameter and height, usually leaving a gap of 0.51 mm on one side. C.tie rods need to be added between the racks to stabilize and reinforce the frame. D.it is not recommended to install sprocket rollers with loose connections such as spring press-in. 2. Female thread A. It is the most commonly used installation method for power conveying such as sprocket rollers, and the rollers and frames are connected into a hole-through bolts at both ends. It takes a long time to install and dismantle the rollers. The rack installation hole should not be too large, in order to reduce the height difference of the roller after installation. The gap is generally 0.5 mm. Taking M8 as an example, it is recommended that the frame hole 8.5 mm. When it is an aluminum profile frame, it is recommended to choose the configuration of large shaft diameter and small thread to prevent the locking rear axle from penetrating the aluminum profile. 3. Flat tenon A. Originated from the Meintroff-Idler group. The two sides of the round shaft core end are milled flat and snapped into the corresponding frame slot, which is extremely easy to install and disassemble. It lacks the restraint in the upward direction, so it is mostly used as the idler roller of the belt conveyor, and is not suitable for power transmission such as sprockets and ribbed belts. About load and load. Load refers to the maximum load that can be carried on the drum that can be driven. The load is not only affected by the load of a single drum, but also by the installation form of the drum, the transmission arrangement and the driving capacity of the transmission parts. In power transmission, the load is decided. Load refers to the maximum load that the drum can bear. The main factors that affect the load are cylinder, shaft, and bearing, and are determined by the weakest of them. In general, increasing the wall thickness can only enhance the impact resistance of the cylinder, and has little impact on the load.